Alright, Physics 35s, this was the question that we were looking at in class. Here's my circuit. I've got a 3-volt power source and I've got a 3 ohm resistor here, a 6 ohm resistor and a 9 ohm resistor in parallel. And the question was, what is the current here? We'll call this current 1. What's that? And then of course we've got current 2 and current 3. What are the 3 currents? So I'm gonna solve for one of them, and then we should be able to substitute that in. I'm going to leave it there. Solving for one of them is the hard bit. Once you've solved one, you can then solve for the other ones fairly easily, I think. So we left off in class basically by looking at Kirchoff's laws, knowing that this is the sum of the voltage in a loop is 0, and the sum of the current at a junction is also 0. That gave us 3 algebraic formulas that we set up in class, and hopefully you can remember them. But the first one, the first formula that we derived in class was to do with the loop of the whole thing, and I said that we were going to use this direction here. So we're going to go round, up through the second one, and this way, and we were going to go counterclockwise. So the EMF is equal to the PDs, which would be the sum of the IRs, and my EMF here is going to be 3. So 3 is equal to the IR here, I1. Sorry, I'm going to put that as 3I1 plus, because this is my IR here, plus 9I2. That's my first condition. Now, I'm just going to leave that for now. My second one is to do with this second loop in here. And again, I think we went with this being counterclockwise as well. So that's counterclockwise that way. Okay, so that means that the 9 is a negative, and my second equation was based on this loop, which said that there's 0 EMF in the single loop, and my positive is 6, so 6I3, oops, and this is a minus, very important to catch the minus, negative because it's going backwards, negative 9I2. Okay, in other words, I can say that 9I2 is equal to 6I3, and hopefully you can see that we're starting to get a ratio going on. Okay, the third one, the third equation that we used was the sum at a junction. So this one here, the current coming into a junction has to equal the current coming out of a junction, which in our case here is going to be I1. Okay, so I'm going to pick this junction here. I1 is coming in, and I2 and I3 are going out. All very nice and straightforward so far. What I'm going to try and do is substitute some things in. Okay, so I'm going to just rearrange this a little bit and hopefully give you a bit of a condition. Let's see if I can do this neatly. Maybe we'll do it just over here at the side. So what I'm going to do is, and I think I did this in class for you, I said that 6I1 is equal to 6I2 plus 6I3. So what I'm doing there is multiplying everything by 6, and that's going to give me this equivalence here. So I've got 6I3. So what I can do then is pull this in to here. Okay, because I've said that 6I3 is equal to 9I2, so I'm just going to switch that out there. So I get, here we go up here, just following this equation up to this point, I'm going to get 6I1 is equal to 6I2 plus 9I2. So now I've got 2 I2s and 1 I1. So I can give myself a bit of an equivalence ratio here between I1 and I2. Okay, rearranging. You're going to end up, if we go to 0, moving both sides, we end up with 15 I2 minus 6I1. So I'm just simplifying this down. And this, of course, is giving me my ratio. This is going to tell me that 6I1 is equal to 15I2. Nice. So there's a ratio. I've got myself a ratio here. I've got myself a ratio here. And now I'm just looking to plug this back into something that I might know about. And I'm actually going to use the Formula 1, okay? Because the Formula 1 has got my 1 and my 2, and that's what I have here. So let's multiply Formula 1 by 2. So I'm just going to take my Formula 1, multiply everything by 2. That gives me 6 is equal to 6I1 plus 18I2. Okay, 6I1 is right there, so now I can bring this guy in here, and hopefully you can see what's going to happen. 6 is equal to 15I2 plus 18I2.
Mr. Johnson,
now I can solve.
Mr. Johnson, please call Tower 2.
I can solve here for I2. Magic. Once I solve for I2, the rest I'm going to leave up to you. Okay, you should get that. The rest is up to you.
Mr. Krishna, please call 2206. Mr. Krishna, please call Ms. Tran. Thank you.
Okay, so just a final word. You know I2. You can now plug this back into any of the conditions that you've said so far and solve for the other two currents. In other words, you can solve for I1 and you can solve for I3. Give that a go, please, and we'll reconvene on this on the next class. Good luck.